Hello, good to see everybody. Happy, what day of the week is it? I lost track. Is it Wednesday already? I'm not really sure. This is a hard problem for me. But welcome back to Ask Math Anything, where what we're going to do is we're going to ask all kinds of questions, and then we'll try to answer all of them as well. The kinds of questions that people ask in this live stream, as we've noticed, typically range across all kinds of things that might have something to do and maybe understandable to people who are studying algebra or geometry. Other kinds of questions that we ask are things like, what day of the week is it? Unfortunately, we have got a lot of people on this live stream who are able to help answer all of these questions. And so I've learned something today. I've learned that it's Wednesday. I think what that means is that the people who are answering that question are in America right now. Because I know that on this live stream, we typically also have some people who are watching from other parts of the world. And they would not say Wednesday, would they? They might say Thursday by now. Regardless, welcome to this show. If you are here for the first time, you'll notice that the show's content is entirely driven by you. And this is the fun part. You can ask anything that you're curious about, and I'll try to make some kind of a lesson, if I can, make it understandable to people who are studying this algebra or geometry. Now, another thing. Yesterday, there were some people on this live stream who decided to ask me an insanely difficult question, the hardest question on an AMC 10. I would like to request, please don't ask that kind of question, not because it's too hard, as you saw we did it, but so that we don't want to make this live stream too hard for all people who are watching. So please be considerate, and please ask questions that are as understandable as possible to everybody who is watching. I chose a question yesterday that looked innocent, and I was like, it shouldn't be so hard. And it took us basically like 20 minutes or 30 minutes to eventually solve. And unfortunately, I wonder if that was maybe a bit too hard for some of the audience. Today, we're going to try to be a bit more careful and choose things that are more understandable. All right, what shall we discuss first? Let's find out. Okay, this is one that looks, maybe it's not impossible. Let's go and try this one, okay? Famous last words. Maybe this one is really hard. This is by Le Mi, and is asking if I draw a pentagram. Ooh, what's a pentagram? I guess a pentagram looks like a pentagon with a star inside it. And the question is, how many triangles? Okay. If I want to go and count all the triangles, is this going to be as hard as the problem you gave me last time? Last time you asked me a question saying, how many points of intersection are there if I go and take an octagon and draw all the diagonals? And so now the question is, what do you mean by a triangle? I mean, I can count for you. Look, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Is that what you want? Well, I think it depends on what the question means. If the question is asking how many simple triangles like this there are, then I'm done. But then that would be like a kindergarten question where all I have to do is count to 10. I see all these people saying no, no, and that's because there are some harder triangles in this picture. The problem is that this is a triangle also. Oh no. So now we've got to count all of these also? So we've got to count the little ones, we've got to count the medium-sized ones. Oh no. Are we ever going to finish this problem? Let me take a sip of water. Someone says maybe it's something closer to 20. Let's see. Oh no, I think I bit off more than I can chew, in the sense that I was hoping this would be very, very easy to solve because there might be a nice insight that will do it. Unfortunately, it's not so simple. So unfortunately, there's not a nice, simple insight that will solve this problem for you. Is that true? If you're new to this live stream, you'll find out very soon that I'm extremely lazy. Extremely lazy. So whenever I look at a problem, I always try to think, is there some way I could do this where I can be as lazy as possible? And the answer is unfortunately not really. Okay, so we have to actually do some work. Fine. If I want to do some work, I will say, let's go and break apart the different kinds of triangles, okay? So I've got the 10 simple triangles. Let's say there are 10 with only one like only one part. Let's just say that. Okay, so I've got some kinds of triangles which have only one part. But there are also other kinds of triangles. I'm thinking about this, and I'm trying to say, I'm actually really lazy. So if I have this, is there any other way I could try to do this problem? Just so you know what I'm thinking about. What I'm thinking about is that there's something nice, which is that whenever I have 3 lines, somehow any 3 lines typically make for me a triangle, but not really any 3 lines. There are some triples of lines that don't make triangles. All right, so let's first try to do things in a way where I can attempt to be lazy, but I'm a little bit worried it might not be so nice. Okay? So what I'm saying here is that, you see, if I went and picked any 3 lines, like here's a line, and here's a line. Hey, 3 lines make a triangle. Maybe that would be nice, right? So if I did that, oh wait, you said the pentagram is only the star, no pentagon? Are you sure? I'm not entirely sure what is the the pentagram is just a 5-pointed star? If that was the case, then the problem is too easy. So I don't want to do that problem. If it's just a 5-pointed star, it's like, we could actually even count that. So if that's what a pentagram is, I didn't realize a pentagram was just a 5-pointed star. Instead, I'm going to ask this question, which is, I went and drew a pentagon and I drew a 5-sided star inside. How many triangles are there? Let's do that one. Let's do this one, okay? And the reason I want to do this one is because it's harder. I cannot just count it. And so when I look at this, I'm saying, look, if I pick any 3 lines, a lot of the times, it gives me a triangle. A lot of the times. So that means I should say I have 10 lines, right? I've got the 5 on the outside, and I've got the 5 on the inside. So I have 10 lines altogether. New approach. So the thing here was nice, but here's another idea. There are 10 lines. And when I pick 3 of them, I often get a triangle. Choose 3, and you get a triangle sometimes. Most of the time. How often? Well, sometimes you don't, okay? Most of the time. Let's not say most of the time. Let's say sometimes first. I don't know how often it is. I get a triangle sometimes. And in particular, this is one example where I pick this line, that line, and this one, and they make a triangle. The 3 lines border a triangle. So what's 10 choose 3? 10 choose 3 is equal to 10 times 9 times 8. Anyone who's watched this live stream before knows that this is where I will most likely make a mistake of multiplying or dividing wrong. 3 times 2 times 1. 2 and 8, that gives a 4. 3 and 9, that gives a 3. Oh my goodness, this is huge. It's 120. Okay, but there's a problem. Some of them are bad. Sometimes you get 3 lines that don't make a triangle. How? Well, let's go and draw this. So how could I make 3 lines that don't make a triangle? Well, I guess I have different ways. I see one way I could make a not triangle. If I pick 3 of these things on the outside, right? If I go and take any 3 where all 3 are on the outside border, that won't make a triangle. What do I mean by won't make a triangle? It's that I would have to continue them. I would have to continue the lines, and that wouldn't work, right? You were looking for triangles inside this picture. So I would say anything where I picked all 3 from the outside, that's bad. And what I'm about to do is I'm going to try to categorize like how many ways I can get a bad set of 3 lines, and I'll categorize them based on how many of those lines are on the outside border. So I've got one case, which is all 3 lines are sides. Those are bad. And the number of ways to do that is there are 5 sides on the outside. Choose 3. So that's 5, choose 3. If you've never seen this before, this is like counting how many ways there are to choose a certain number of things from another bunch of things. And the best way to learn that is to just see a lesson directly about that. But for these questions and answers we do here, we're just going to we're going to assume people have seen it before. And 5 choose 3 happens to be 5 times 4 times 3 divided by 3 times 2 times 1. It's actually the same as 5 choose 2. and that gives you 2. It's 10. Okay, so I'll get to subtract 10. It's not 120. I'll subtract 10, which are made by taking 3 lines where all 3 are on the outside edge. How many ways can I make it bad if I have 2 on the outside edge? Oh, this looks horrible. Now I'm starting to regret that I chose this question. Let's see. Suppose I have 2 lines on the outside edge. If I have 2 lines on the outside edge, you know, like this, and then 1 line in the middle, now you see that's totally not a triangle. But I'm starting to see some nice pattern, okay? So if you have 2 of the lines are on sides, well, it turns out that if 2 of the lines are on the sides, there's really only one way, I think only one way to get a triangle. If you do 2 of the lines on the sides, sorry, not only one way, there's only 5 ways to get a triangle. If 2 of the lines on the sides, only 5 ways to get a triangle. And what are those 5 ways? Oops. Those 5 ways look something like this. 1, 2, and 3. And then that's 1, and I just kind of rotate it around. Oh, someone's saying 10 ways. Did I make a mistake? So if I have 2 of the lines on the outside, I think the only way I could make a triangle is if those 2 lines touch each other, and then the other edge has to actually be this one. There's no choice. So there's like 5 of these that are legit. But by the way, how many ways are there to put 2 lines on the outside edge? The number of ways to do 2 lines on the outside edge. Number of ways to have 2 lines on sides is equal to, there are 5 sides altogether. Choose 2 of them. So that's out of the 5 sides, I'll choose 2. Times, there are 5 lines inside. So here are the ones on the sides, and here is the inside. Because there are 5 sides to pick from, I'll choose 2 of them to be the 2 lines that, 5 sides like this. I'll choose 2 of them, and then I'll also choose one of the inside ones. That's times 5. And 5 choose 2 was 10, so that's 50. Ooh, neat. So I get to subtract out a huge number. So now what I find out is, how many bad ones are there with 2 sides on the outside, with 2 lines on the outside? The number of bad ones with 2 lines on the outside is exactly 50 minus 5, because 5 of them are good. So the number of bad with 2 lines on sides is equal to 50 minus the 5 up there, which is 45. Okay, we're almost there. Because now I'm going to say I'm just going case by case by case, right? First, what I did is I said, hey, let's go and find out all the ways to pick 3 lines. 3 lines is 120. Next, let's find out how many ways I am bad. So I subtract from the 120. What kind of bads do I have? Well, if I have all 3 of the lines on the outside, that's always bad. 10 ways to be bad. Next, I can say, well, I could have 2 of the lines be on the outside and 1 on the inside. The number of bads is 45. Then let's go one more step. How about if I have only 1 of the lines on the outside? How could it be bad? If you have only 1 of the lines on the outside, I'll just use that one there. How could it be bad? Okay, so this is only 1 line on the side. How could it be bad? Well, I need to now choose 2 of those lines which are inside. How could I make a not triangle? Actually, lots of ways, right? So if I put this thing here, how many ways could I make a not triangle using this one pinned down there? Let's see. Maybe what I should do is I should almost say how many of them actually make a triangle. Yeah, let's do that. That's easier. If there's this one on the side, how many of them are actually going to make you a triangle? If I'm only allowed to use the lines that are going through the inside next, I think there's actually only one. Yeah, if there's only one on the side, there's only one way to pick these two inside ones to make a triangle. It feels a lot like the calculation I just did on the other problem. So if only one line on the side and two other lines inside, then only, let's say this, only one way to finish the triangle. I said the word finish because that means that there are 5 of such triangles. 5 of such triangles with 1 on the side and 2 inside. Just rotate this around. So there are 5 of them. So that means that there are 5 good triangles with 1 line on the side and 2 lines inside. And now I do the same thing again. I go and say, all right, but how many different ways were there to pick 1 here and 2 inside? But the number of ways to pick 1 on the side, 2 inside, is equal to the same calculation as before. 5 of these sides that I can pick on, times there are 5 inside lines, choose 2 of them, that's 50 again. So what I find out here is that there are 50 minus 5 bad ones where there's 1 on the side. So the number of bad sets of 3 lines with exactly 1 on the side is equal to 50 and then minus 5. Another 45. Uh-oh, is there going to be anything left? I'm going to have trouble now. Let's see, where am I starting? I'm starting from 120, then I'm going to minus 10, and then I'm going to minus 45, and then I'm going to minus 45. Am I at 0 yet? What happened? So far it's 20, I think. So it looks like so far I have 120 minus 10 is 110, minus 45 minus another 45, that's minus 90. So far I got 20. So that's a problem because I saw some people thinking that the answer is bigger than 20. So far I got 20, right? I got 20. But I still have to think, how many more bad ones are there? How many bad ones are there with no lines on the outside? What if I have all 3 of the lines on the inside? Something's telling me that if all 3 of the lines are on the inside, I think it's always legit. What if all 3 are on the inside? If all 3 are on the inside, it might look like this. 1, 2, 3. Hey, that looks pretty legit. All 3 on the inside, it's like, that's a triangle. And actually, no matter how you try to draw 3 lines which are all on the inside, it will always give you a triangle, I think. Ah, this is neat. Really? That's kind of nifty. I didn't expect that to be the case. Really? I'm now thinking about this from like a combinatorics point of view. It's like I have 5 lines inside here, and I choose 3 of them. Then it's almost telling me there's 10 of them. I'm having trouble believing this, because I don't exactly see 10 such triangles. Wait a second. So I see that if I did this, that would be 1. What does another one look like? Oh yeah, I could believe this. I could believe this. Because I was going to say, that looks like, I think I could get 10. Yeah, I believe this. Okay, so actually, no matter how you draw it, there's 2 kinds that you'd make. If you go and pick 3 of the lines on the inside, if the other way would be something like this. This one, and this one. And that also makes a triangle over there. Right? So what I'm saying here is that no matter how you choose 3 of the lines on the inside, that will determine for you 1 triangle. So when I put everything together, it looks to me like the number of bad triangles with all 3 sides well, let's say all 3 lines inside is equal to 0. Okay, and in that case, if I go and look at what's left, it's like, well, I had my 120 minus the 10 minus the 45 minus the other 45. Looks like 20 is the answer. Really? So it looks to me like answer is equal to 120 minus 10 minus 45 minus 45, which is 20. I'm actually not sure if that's the right answer. I now know that some of these people have been doing this problem, so I'm a little bit curious. If anyone got more than 20, I'm a little bit curious. Somebody got 28. If you got 28, are you sure you didn't double count anything? Because I'm a little bit curious. It could be that I made a mistake. Let's see. So we got some disagreements here. Got 40, 60, 35, 35. If that's the case, then we now need to figure out what the actual answer is. So whenever we're doing all of this, I see somebody asked, where is temp ID? We need some help. So now let's take a look. Oh, yes, thank you. Qing Yun Tang is asking, what are we talking about? We're trying to solve this problem, and we don't know the answer. The question is, suppose I drew a pentagon, and suppose I drew a star inside the pentagon. And then the question is, how many triangles are there in this picture? Were there different kinds of triangles? Some kinds of triangles are like this little tiny ones. Some kinds of triangles are like a little bit more sophisticated, like going with here, and then here, and then here. And some other kinds of triangles might even be kind of going all the way across, like this. And the question was, how many triangles are there here? And so if I wanted to go and check the work that we just did, the work we just did was to say, there are 10 lines that you can play with. 10, choose 3 of them. Is 10 times 9 times 8 over 3 times 2 times 1. That one seems okay. That's 3 times 4, that's 120, okay. And then what happens next? Oh, somebody checked online, and some of the websites said it was 11, but it can't be 11 because somehow everyone has more than that. I'm actually quite curious. If our moderator team can also help to check this answer, that would be very helpful. But as I'm continuing to look, I'm just checking the work right here. And I'm saying, well, let's now get rid of the bad ones. Bad means I picked 3 lines, and when I picked 3 lines, maybe I picked all 3 lines which are on the outside. If I pick all 3 lines on the outside, that's definitely going to be bad. But the number of ways to do that is there are 5 edges on the outside, choose 3 of them, then you take away, that would be 5, choose 3, which is actually 10. The next thing, I see a lot of people are saying 35, so that might mean the answer is 35. So let's continue checking the work. The next is, how many of these bad triangles are made by having 2 of those lines which are here on the outside? If you have 2 lines on the outside and 1 line on the inside, then how could it be that that was a bad triangle? And it's easier to say how many of them are actually good triangles. The number of them that are good triangles are if the 2 edges on the outside touch each other. And if they touch each other, the only thing you can do on the inside, is to use this one, okay? So then in that case, like there are 5 of these that are good, and the number of ways to pick 2 from the outside is 5 lines on the outside, choose 2, that's 5 times 4 over 2, that's 10, times there are 5 inside choices, so there's 50 of them. And so if I take 50 minus the 5, there are 45 bad ones over here. Okay? Next, let's see. Meanwhile, I'm still checking. If the moderators actually have found the answer, that would be very useful. So the next one is how many of these are bad if I have 1 of these lines on the outside. Ah, yes, that's where there's a mistake. This is good. This is good. So now I like that we're going to find a bigger answer now. Actually, we don't need that the triangle is a perfect triangle where this side is the entire side. There are more good ones here. Actually, if you have one side which is here, hey, look, here's another good one. Aha, we found the mistake. See this? That's also good. The reason that's also good is because this is a triangle. Actually, most of these are good. If one is on this side, how could it be bad? Oh, this is really interesting. Okay, so this is where the mistake is. And this is how you check your work, right? The way you check your work is you go and say, all right, let's go and reason with everything. And since we broke everything into cases, this is going to be the place that we have found the mistake. So now let's do this one with more care. How many ways can I actually make something good out of this? Well, first of all, I can see that if I want to use any of these lines that are going through, I better use lines that actually touch these two edges. That's for sure. Can't you just count the triangles? You might be able to, but the problem with just counting the triangles is if you count wrong. I'm showing you a way that is easier to sort of make sure that you don't count wrong, because you can replay the argument and you can figure it out. So now what I need is I need to have two lines. One has to originate from this part, one has to originate from that part. That's how many are good. As long as I have this blue line here, and then some other line coming out of this, matching with some other line coming out of this, that will make me a triangle. Perfect. So that means not one way, there are only 4 ways. Actually, let me be clear about how I got that 4. There are only 2 times 2 ways to finish the triangle. You know why I said 2 times 2? It's because if I've got this line here, I have 2 things coming out, this one or this one, choose one of them. I've got 2 things coming out of here, choose one of them. Any connection of one of these and one of these will make you a triangle. So there are 4. And so now the number of ways, that's 4 ways to finish, and therefore there are 20. This one goes into a 20. Now I agree with the 35 people. This becomes 20. The reason this becomes 20 is because there are 5 ways to choose this blue base times 2 times 2, and that's 20. If that's 20, now I change this 5 into a 20. Perfect. Now the answer is 30. And this is how we check our work, because now we have 30 here, right? So if this is 30, which is the number of bad triangles which happen to have one length on the outside, now we just go and change this part into a 30. And so since I subtract 15 less than I used to before, my answer will go up by 15, and I now agree with the crowd that got 35. So I think the answer is 35. Was this the most efficient way to do things? I don't know. What I wanted to show is that this is a way that you can actually go and you can replay the whole argument. You can replay the logic. Counting is dangerous because if you just go count, what if you count wrong? I saw some people have counts that are like weird prime numbers, which, probably not. And if you go and search it online, that's the other way to make sure you got it right. If you searched it online, you would find the answer is 35 and then you'd be done. But that's not fun. So if you actually did it systematically, saying here are all the different kinds of triangles that you might have, that would be a way to get 35, and congratulations for doing so. I'll tell you why I was scared of that. The reason I was scared of that is I was afraid of maybe possibly forgetting one kind of triangle, and so that's why I went down from the top instead. But you see, I went down from the top, and the way to check is if you go up from the bottom. It's like what I was analyzing is I was subtracting and subtracting, and you guys got bigger numbers. So I was like, well, if you actually found more triangles, then I probably subtracted too much. Okay, well, that was fun. Thank you very much for asking a question that I didn't answer and instead decided to do a much harder problem, half an hour for one problem. But hopefully this was somewhat interesting to see how you can use counting to hopefully reduce, to give you a reasoned way of getting a definite answer which is not based on just looking. All right, what other questions can we have? Maybe let's try to pick something a bit easier. Oh, yes, Umesh Dubey has asked, can we write a program to obtain the answer? If you wanted to use a program to obtain the answer to this question, I can tell you how you could. One way you could make a program for this is you could make something where there are these 10 lines, and you can actually have computer programs to detect whether lines intersect. So really what's going on here is I needed to get 3 lines so that all 3 of the lines actually intersect or they touch. The time when it breaks is when you have some lines and some pairs of them don't touch. You will have a triangle as long as you have 3 lines and every pair of them touches somewhere. Because in this picture, I have no situation of 3 lines going through one point. So you could actually write a computer program where you have all of these points and you generate from those points the 10 lines and you look at all the sets of 3 of the lines and you go and check if, given the set of 3 lines, every pair of them actually intersects. That's how I would do it. More questions? Hmm. Oh, here's a question that's about math competitions. Sahiba Kaur has asked, is it, I'm trying to pronounce the name right. Is it Sahiba Kaur? I hope so, or Kaur. What you asked is, Professor Loh, are you hosting MOP this year? Yes, there will actually be an online version of the Math Olympiad training program this year. And we will be doing that sometime. We haven't completely settled the dates yet, but it's going to be sometime in the summer. But we are going to try to do as much as we can, even though we can't go in person. Okay. Fri June has asked, what is Po-Shen Loh's first video? I think that the first video that I was really involved in on YouTube is one which is called The Most Beautiful Equation in Math. This is the one that we made at Carnegie Mellon University for Pi Day. And all we did is we just sat in a room with some interesting people, and somebody turned on a camera and recorded for a while. And then this video somehow got onto YouTube and got a lot of people to look at it. It's the CMU Pi Day video. That was my first, I think, appearance on YouTube. More questions. Oh, I see. While I was doing this problem, someone had suggested, if you choose any 3 points, won't it form a triangle? The situation with this kind of a problem is if you choose 3 points, it does form a triangle if the 3 points are on the outside. But there are some ways to choose 3 points, like this one, maybe this one here, and then that one there, and they don't form a triangle. So that's why I used the lines instead. Somebody asked about the volume levels. Gee, I'm not entirely sure what's going on with the volume levels, other than my excitement level typically fluctuates based on how close we're getting to the answer. Oh, we were still curious about writing a program in order to do this. So Umesh Dubey has asked, what platform or programming language can be used to write such a program? Well, I think, in fact, the way to be most sure about this answer is if you wrote the program in Wolfram language, the language of Wolfram Alpha or Wolfram Mathematica. It is actually possible in that language to encode these points. And why I said that language is because these points have coordinates that are possibly irrational numbers with the square root of 5 inside them. And Wolfram can drag those numbers around. It would actually work. Although actually, if I was doing this in, say, C++, which is what I would probably do, I would change all of these coordinates into integer coordinates. Because you can. You see, because the answer to this problem of how many triangles are here, the answer is exactly the same as asking how many triangles are in this picture. Doesn't it look exactly the same? I just want to know how many triangles are in this picture. Well, I actually, by putting the picture this way, I chose some convenient coordinates. I mean, maybe this guy is at 0, 0. But this guy over here is already at -1, 2. This one here is something like 2, 0. And this thing here is at 3, 2. And this one up here is at where is it? 1, 3. So this is not like a very symmetrical pentagon. But if I draw a pentagon and these are my coordinates, the number of triangles inside is the same as the number of triangles if it was regular. And so I would actually use C++, use exactly these coordinates, and then do that program. And I would have no problem about having to worry about like the square root of 5. Okay, more questions. Oh, AC said you drew a picture of me on Saturday. Did I receive it? I did, actually. Thank you very much. I'm always amazed when people do stuff like that. Thanks. Okay. I'm trying to find something that might go a little bit easier, because I don't want to make this thing just go nuts. Okay. Oh, these kinds of problems. Let's do this kind of problem. I'm wondering if we can try to do this one quick. And when I say do quick, what I mean is maybe we can show you a nifty way to do these kinds of problems. So this is, oh, what a username. This is from Pennywise, the Dancing Clown. The arithmetic mean. So the arithmetic mean of Josh's 4 test scores is equal to 80. And now suppose that 3 of them have an arithmetic mean of 87. And now the question is, what's the score on the 4th test? Okay, how do you do these kinds of questions? Now, when you do this, there's one way to do it, which is just to kind of, oh, well, if the average is 80, then the sum is 4 times 80, right? I see that some people are saying this is easy, but maybe it's easy for you. I want to discuss this in a way that hopefully shows to people a nifty way of thinking through all of these, where you can do as little calculation as possible. Like the big calculation way is to say, look, the average of 4 is 80. So that means the sum of them is 4 times 80, right? I could do it in the slow way. Someone says Josh isn't studying. Well, you never know how hard this test is. The test that I give at Carnegie Mellon University, the average score is like 50. But that's, of course, because the tests are actually just really, really, really hard. In the test that I give in my class in this university, actually, if you get more than 50%, you're doing pretty well. Okay, anyway. So this, and of course, I curve the grades. It's not like the F is 60%. Actually, somehow the line for the A might be something like close to 50% in the first place. Okay, let's continue. So if the average of these 4, the slow way is to say that the sum of all of them is 4 times 80. And then you want to say that the sum of these three is equal to 3 times 87, and then you could just subtract. You could take 4 times 80 minus 3 times 87, and people think it's 59. But I'm too lazy to do that. So the way I often think about this is, if the average is 80, and 3 of them have an average of 87, here's another way to think of it. 3 of them have an average of plus 7. So I'm just saying that somehow my benchmark is 80. It's as if you said, all right, so yeah, I mean, I have a new scoring system. My new scoring system is 80 is the new 0. Or rather, I'm just saying 80 is the baseline. Come on, like, how are you compared to the average? Well, 3 of them are, on average, above average by 7. Okay? Exactly. 80 minus 21, Harry Liu. That's it. I'm basically saying that 3 of them are plus 7 above the average. So if you were trying to balance everything, and you said, look, my average is supposed to be this mysterious number, which I'm not going to tell you, but 3 of them are already up by 7, up by 7, up by 7. How are you going to counterbalance that? The only way to counterbalance 3 of them being up by 7 is for the 4th to be down by 3 times 7, right? It's like up by 7, up by 7, up by 7, so the other one has to compensate by, 21. So if that's the case, then the 4th one is down by minus 21. So that's actually, to me, the fastest way to do this problem. If the 4th one is down by the 21, 80 minus the 21 is equal to 59. I actually find these kinds of questions quite fun, because all you have to do is you just have to look at the average and say, forget about everything else. We'll just consider the average to be the baseline, and we'll deal with it later. We put it back later. Okay, more questions. I see there was a question saying how many triangles are there in a trapezoid. I'm not really sure what that question means, so I'm afraid I can't quite answer it, because a trapezoid to me has only 4 sides, in which case it has 0 triangles. Oh, some questions about programming have appeared. So Sophie Zhang has asked, what's a good age to start learning programming? Honestly, now. I mean, it's never too late. You just go and try to figure out how to make a program to do something for you, to like calculate some numbers, or just figure out how to force a computer to do something. The sooner you learn programming, the more powerful you'll be, because occasionally in your life you'll say, oh, there was this task that I had to do which is really boring, but if I just wrote a program to do it, I can be done faster. It's never too early. If you are watching this live stream, I'll say, you can already learn programming now. And you can just go find some stuff online and go mess around and make something, and you'll feel powerful because you just made the computer do something. Okay. and a house that, that's slavery, making the computer do something. Well, I'm not going to comment on that. That term's actually a fairly loaded term. But I'll say that for me, when I was learning computer programming, the reason why I enjoyed it is because finally, here's a computer, and it would be willing to do all kinds of things. It would be willing to do lots of computations. And at a time in my life when maybe I couldn't really tell everyone else what to do, I felt that at least I could make the computer do what I wanted to do. Okay. Again, I'm trying to find questions that might be at a level that would be good to do. Oh no, one of these broken calculators again. Is this a different question? Let's find out. Colin Z has a broken calculator. It's puzzle time, puzzle time. So, broken calculator. And in this broken calculator, if you put in 86, you get 44. When you put in 14, you get 5. And when you put in 53, you get 18. And what do you get when you put in 49? Not 7. Question mark. Okay. Anyone see a pattern? Well, I see something interesting. As I'm writing all of these down, immediately I noticed that somehow 8 plus 6 is 14. 1 plus 4 is 5. 5 plus 3 is 8. That seems kind of nice. I see that Kenna Zhang has asked, why are calculators always broken? That's a good question. But let's see. So Harry Liu, I agree with you. I think the digits add up to the ones digit. Not just Harry Liu. Geometry Jake also. A bunch of people all said this. It looks like the last digit is the sum of the digits. Has something to do with the sum of the digits. Okay? So this one has something to do with the sum of the digits. Great. But if that's the case, what would I do with the front? Right? So here's a 4. Here's a 0. Let's just write a 0 because I think that's what's going on. What would be reasonable? How do you go and get 1 out of 5 and 3? How do you get 4 out of 8 and 6? The sound got quiet, apparently. Oh, I have an idea. So I'm going to make a guess. You know what happens if you multiply 5 times 3? 5 times 3 is 15. So first of all, I'm going to say the last one is the sum of digits. Oops. Last digit. But there's something interesting going on with these first digits. You see, 8 times 6 is 48. It's 48. 1 times 4 is 04. 5 times 3 is 15, which is a 1, 5. Something to me is saying that maybe this is the product of the digits and the tens digit. I'm not sure if this is what the problem maker was thinking of, but 4 plus 9 is 13, ends in a 3. 4 times 9 is 36, so I'm going to guess that it's 33. That's my answer, and I actually don't know whether that's the right answer or not. We'll find out soon. But I guess I'll say it seems to me like a legitimate answer. It's an answer that's defensible in the sense that I could tell you these 2 rules and everything else would satisfy it. Oh, the real paper boy says correct. But are you the one who asked the question? I actually lost track of who asked the question. But in any case, seems reasonable. Okay, more questions. What else do we have? Yes, AC says it was the same concept as the last problem of broken calculator. Yeah, maybe this is how all calculators break, obviously. Yue Cai Zhu asks, why do we say that the triangle is the strongest shape? This is an important physical type question. See, if I draw you a triangle, and I tell you I have a triangle with, that's hard to read. I have a triangle with sides of length 7, 10, and 11. Suppose that's what I tell you. Guess what? There's only one triangle like that. And this is also called SSS congruence, but you don't really need to think about that. It's like if I have 3 sticks and one stick is 7 and one stick is 10 and one stick is 11, you try to put these sticks together, there's only one triangle. There's only one triangle. 7, 10, 11. Now, the reason why it's so useful that there's only one triangle is because if you try to smush this, if all three are sticks and they're all really stuck together here, here, and here, and you try to wiggle, it's not going to wiggle. It's just going to stay. But the problem is if I tell you that there's a quadrilateral, with sides, we can even use nice sides. Sides of length 7, 7, 7, and 7. Hey, can you tell me what that is? Obviously, it's a square, right? How many quadrilaterals are there which have sides 7, 7, 7, and 7? Oh no, it can fall over. You could have a square that looks like this. Or you can also have something that got smushed. Also 7, 7, 7, 7. So unfortunately, we can't really build a house where we only have squares. And so what you want, and actually, yes, this is called a rhombus. But what you want is if you want to have a strong house, you want to draw another line in between. You basically want another bar, and that other bar forces the triangles to stay put. So I think that's why many people consider the triangle to be the most stable shape. More questions? Christine Zhu asks, can I have a free spot in your CMU class? Choose me. Well, come join us at some point in the future here at CMU. Carnegie Mellon University is a college, and I don't know what grade you're in, but at some point you might apply to college. Actually, all of you on this stream. Someday I might actually see you guys applying to college. Who knows, in some number of years. Yeah, and if you do come to Carnegie Mellon University, we'll have different kinds of classes. We don't only teach algebra and geometry here. Okay, more questions. Oh, here's a fun trick question, okay? This is from an AMC 8, but fortunately it's not the hardest question on the AMC 8. There's a set of numbers. Let me write down the numbers. -8, -6, -4, 0, 3, 5, and 7. Oops. Curly brace. Curly brace. That's a set. And the question is, what is the smallest possible product of three numbers? Of three different numbers. From that set. What should you do? Well, obviously, it's -8 times -6 times -4, right? Well, we got to think a little bit. On this one, we have the negative numbers. So smallest possible is like negative huge. So now we know our goal, negative huge. So if we want to go to negative huge, we need to figure out a way to make negative. How do you make negative? You either make negative with all three minuses or with one minus. All right? So there's two ways. And that's how I'm showing you how you'd analyze this through and not make a mistake. Case 1. Only one negative. And I guess we have a case 2. All three are negative, right? Because there are only three anyway. There are only three negative numbers anyway. So the case number 2 is just -4 times -6 times -8. Which is negative of 4 times 6 times 8. But I'm not calculating it out because maybe I can save myself some work. What else could I do? If there's only going to be one minus, oh, that's obvious. I should pick the -8 because I should be as huge as I can. Okay, so -8, that's the hugest, the most minus. And I guess I should pick the 5 and the 7. Now I go and ask, which is better? Should I go -8 times 5 times 7? Or should I go -8 times 4 times 6? Oh, it's much better to choose this one because the 5 is more than the 4 and the 7 is more than the 8. So this one's going to be more minus. This is minus 5, well, let's write it in the order that it was, minus 8 times 5 times 7. And so that's the more minus one. 8 times 5 is 40. That's convenient. 4 times 7 is 28. So I'll get an answer of minus 280. And I hope that's the right answer. I actually don't... Oh, I see that this was actually a question with multiple choices. And minus 280 was indeed one of the choices in these multiple choices. So that's probably right. Okay. More questions. Right, and this is an example of like a trick question. Sometimes when you look at it, you say, oh, just grab the 0. But no, you have to go and think about these negative things as well. Oh no, 7 is more than the 8. Is that what I said? Oops, I meant that the 8s are both here. The 5 is more than the 4, and the 7 is more than the 6. Okay. Oh, someone's asking about math counts. Cool Kid has asked, why did you get involved in math? Why did you get involved with math counts? When I was younger, I got involved with math counts because my teacher said, here's something that looks like maybe it'll be up your alley. Why don't you give it a shot? And I thought the questions looked hard, and I was curious. And nowadays, I get involved with math counts because I feel that that's what got me interested in math. So I like to help get more people interested in math by showing them how interesting these hard questions can be. Like what we're doing on this live stream right here. More questions. So Diane has asked how to take preparation for all these competitions when you're overwhelmed by so many other resources that you could look at. This is where I think it's very important that you choose your resources carefully. And I think that the best thing to find for yourself is resources that I guess you find are inspiring, as well as resources which keep challenging you, where you don't quite know what to do, but then you go and figure through it. It's like what we're doing right here in this live stream for me. I'm the one who's challenging myself right now because you guys are giving me random questions, and sometimes I calculate them wrong. And then I'm just using the fact that there are 235 people watching to go and be like, oh, you guys are probably right. There's a wisdom here in this crowd. And then I'll go back and say what's wrong and find out what's wrong. So I'd encourage you to go about learning math similarly. It's like how I was just curious. I wonder what happens with this particular problem about triangles in this pentagon with a star inside. And if you have some friends who can go and discuss the question with you, then afterwards you can also go and check and compare your answers. I'm going to acknowledge that I see some people asking questions about sines and cosines, and I'm not going to discuss those because I'm worried that those will go beyond the level of what we want to hit in this live stream. So we won't be hitting those here. This is a cute puzzle. I'm curious what the answer is. It's from Judy and Andy. Or Judy Andy. And Judy Andy has put down a number. 9, 8, 7. Let me leave some more space. 9, 8, 7, 6, 5, 4, 3, 2, 1. And Judy Andy says, put plus signs to get 99. Okay, that's a challenge. Where can we put plus signs? I hope this is possible. Okay, so I'm going to say that I probably, since I can only put plus signs, I don't dare to put 9 and 8 together into a 98 because pluses it'll kill me. It's too much. So I have to do 9 plus 8. Of course, if I just added all of them together, 9 plus 8, let's try that first. If I just do a big ol' addition, we've seen this before. This particular addition, when you add everything together, the answer is equal to how many of them? How many? Multiplied by the average. And the average is the same as the average of the smallest and the biggest, or the first and the last. So 9 plus 1 divided by 2. And so that happens to be 45. Now, if I have 45 already, that's telling me I want to get 54 more, right? This is how I'm thinking of where I start to smush some numbers together. I need to get 54 more. So I already have 45. In order to get 99, I need 54 more. need to smush to get plus 54 more. Now that gives some suggestions. If you smush together the 5 and the 4, that'll give you a 54. But it won't be 54 more because I lost 9. So the next thing I can try is, what about smushing the 6 and the 5? I'm showing you how you'd think of this. If you smush the 6 and... it's going to work. See, if I smush the 6 and the 5 together, watch this. Smush this together. I'm not sure that actually even looks like what we want to write. That just looks like a weird lightning bolt. But let's just say smush. Smush is a technical term in mathematics now. Well, if I want to smush this together, instead of getting 6 plus 5, I get 65, right? So what's my gain? My smush goes from 6 plus 5, transforms into 65. That's an 11, transforms into 65, and that's a plus 54. So boom, that's how I do this, right? So you make a lump, right? That's what we're doing. We're putting these together to make a lump. And if you do that, you get 54 more, which is exactly what we wanted. And so the answer is put plus signs everywhere, except not there. Boop. So when I take that one out, then this whole thing adds up to 99. Done. I wanted to show you how I went to think about this. One way to do this problem would have been just to be like, hey, let's put some plus signs here, there. And you see the way I started is to say, I'm scared of putting a plus. I mean, I have to break up the 9 and the 8. If I let the 9 and the 8 come together, they make 98. And that's way too big. And then I looked at these and I was like, gee, what do I want to put together? So let's start by just breaking them all apart and finding out what I've got, and then start putting them together. So that's a suggestion of how to do this kind of problem. Okay, thanks for the question. That was nice. Now we have about 3 more minutes. This is when we usually talk about some more general questions. Here's some quick answers. Pooja asks, Pooja Malti, is that right? Or Molly? My vision's not very good. You asked, where do I live in? I live in Pittsburgh, Pennsylvania. And that's because Carnegie Mellon University is just down the street. Okay, more questions. More general questions. Umesh Dubi asks a dubious question. Do computers have emotions? I don't know. I'm not really sure I'd say computers have emotions. I think that they're digital. But then again, I don't really know about these philosophical questions. It's a bit too hard for me to answer that problem. I'll just stick with doing the math side. It looks like Evie Shen is asking about tips for what to eat or drink during a math contest. Bananas and water. Some of the people here before already know that that's my quick answer. More general questions. Yes, Carbon News, you're asking, is it better to do problems or lessons if you want to go and, figure out how to learn math or anything else? I would say lessons made up of problems. If you just do problems that come from completely random places where you don't even know how people chose them, that could be a waste of time, because what if the problems you're working on are either too hard or too easy? As you can see, even when I'm choosing what to answer, I'm trying to choose particular problems that I think are the most interesting, that I can use to kind of show you lots of things. And so the best way, I think, to learn is to go and make sure that you have lessons made up of problems. Not lessons where someone just told you, here is how you do this, now practice, here how you do this, now practice. But rather use your summer when you have more free time to go and, try to find some organized problems to work on. Okay. Judy Andy has asked, have you ever been in a debate tournament? Yes, I did this in high school. It was lots of fun. And I highly recommend it. It's actually very useful to learn how to quickly come up with an answer that you can give that makes sense when you're trying to argue a point. And let's see, what else can we do here to finish up these things? I'm still looking through to go and choose like a good question to end on here. Okay, let's finish this one. Yue Cai Chu, how long should you study math per day? Now, you're in the summer, so I think what I'd say is that your day is pretty long. You, at this point in the summer, generally don't have school to go to, so you can decide what you want to do with your day. And I don't know if it happens to you guys these days, but I mean, at least back when I was growing up, at some point in the middle of the summer, you actually get bored because there's nothing to do. It feels really boring. But it feels really boring if you're not like somehow doing something or moving towards some goal. So what I would say is, if you make math like one of the things that you want to do this summer, you can set some goal that you want to make. Like maybe you want to learn a particular course, or maybe you want to do a particular set of questions, and you'll just feel yourself making that progress. It feels good. And so regarding how much time to do per day, I would actually say if you've got the summer, if you can spend an hour doing weird math every day, or 2 hours doing weird math every day, that's good. I don't know what this counts as. I mean, this as far as I'm concerned, this is like entertainment. At least it's entertainment for me. I'm just like playing around with all of you guys. But I would actually say, like, if you have the summer, and if you have the time to put like an hour or two to go and think about mathematics, you'll actually go really, really far. Especially if what you're playing with is not the routine stuff. I don't mean just spend an hour or two preparing for next year by like reading the textbook for next year. I mean like actually going and thinking about some stuff that you don't know how to solve. And that's the fun part. All right. Well, I think we've actually hit the time for today, which is our hour of the live stream. Thank you everyone for coming. I did notice that there are more people today, and that's nice. That actually makes me feel like maybe we'll be able to do this for a longer time. If you do know people who might be interested in something like this, please let them know. And with that, I'll say I'll see you guys all tomorrow.